All right.
Like B. Vector between 2 points. Okay. So we've got a couple of coordinates here. This is 5D, and we've got coordinates A, which is 2, 3, and -1. We've got B, which is -1, 0, and 3. And then we've got coordinates C, we've just got A and B. We've got vector BC, which is 2, 4, and -2. All right, find OA, OB, and AB and state in terms of I, J, K. So we'll introduce some new vector notation to you here. So firstly, vector OA is the vector from point of origin to A. So it's just the coordinates of A, take the coordinates of O. So it's going to be this one, 2, 3, -1. And it says state it in terms of I, J, K. So what that means is it's going to be 2I plus 3J take away K. And so we use I to represent 1 unit in the X direction, J 1 unit in the Y direction, and K 1 unit in the Z direction. So we've got 2 units in the horizontal direction, 3 units in the vertical direction, and -1 unit in the depth direction. Okay, so that's OA. Then we're going to look for OB, which is just going to be that as well, -1, 0, 3, which will be -I plus 3K. We don't write 0J, we just write in terms of I and K. And vector AB, okay? So vector AB is the vector from point A to point B. And I said we do the coordinates of B, take away the coordinates of A. So I've got -1, take away 2. We have 0, take away 3. And 3, take away -1. Plus 4. Okay, the distance between A and B, so that's all part A, isn't it? Now, find the distance between A and B, that's just the modulus of vector AB, right? It's how far apart are the coordinates A and B. Well, we found the vector AB, which is from point A to point B, so we just want the modulus of that. 3 squared plus 3 squared plus 4 squared. So we'll have 18 plus 16, 34. Okay, part C. The distance from point B to the Z axis. Okay, the distance from point B to the Z axis. So, now we're going to answer that. We've got X and Y and Z. Let's sketch it so we can get a rough idea. X, Y, and Z. Now we've got -1 on the X, 0 on the Y, and 3 on the Z. Isn't that interesting? I'll do that there, I'll do that there. So it's -1, 0, and 3. Okay, so the question is, how far is it from this point to the Z axis? 1 unit. Yeah. So we can see that because it hasn't moved any component of Y. Basically, we're just going to consider X and Y, but the Y value is 0. Either way, it's going to be a triangle or a straight line. So yeah, the answer to part C is 1 unit. Okay, how about the shortest distance from A to the XY plane? Okay, so this is the XY plane. All right, it's like the whiteboard is the XY plane, and then I'll have point Z, the axis Z coming in and out. Now point A is across 2, up 3, and into the board 1. Across 2, up 3, and then into the board 1 unit. All right. So point 2 and 3, that lies on the XY plane. So how far off the XY plane have we moved? 1 unit as well. Okay. So from, look, the XY plane anytime you're confronted with the distance from a point to the xy plane, that's just going to be the z coordinate. All right. If it's an xz plane, well, it's going to be the y coordinate. All right. And so the z coordinate is 1 unit, or it's a value of 1, so it's 1 unit off. All right. Is that okay? All right. So then we have find vector AC. Vector AC. So, if we want the vector from A to C, all right, what we know so far is we know vector AB and we know vector BC, and so vector AC is going to be vector AB plus vector BC. And the reason that's the case is because my first letter is the first one I have here, and my last letter is the last one I have here, and these are the same. Okay, vector AB plus vector BC. And to sketch that, what it looks like for you, if this is vector AB, the vector from A to point B, and then we have vector BC, which is the vector from B to C, well, vector AB plus BC gives you the resultant vector of AC. Remember, we're just connecting heads and tails. All right, so vector AC then, we've got AB and we've got BC, we'll just add those together. Write them both here so we can see it. -3, -3, 4, plus, and then vector BC, 2, 4, -2. It's going to give us -1, 1, 2. Okay, so that's vector AC. Find the coordinates of C. Find the coordinates of C. Alright, so what that means is we want vector OC. Alright, because vector OC is going to tell us the coordinates of C. And vector OC is the same as OA plus AC. Yeah? So, OA, I wrote it out, that is 2, 3, -1. And AC, we've got down here, -1, 1, 2. Add those together. 2 and -1 will be 1. 3 and 1 will be 4. -1 and 2 will be 1. Therefore, C has coordinates 1, 4, 1. Alright, so all I'm doing there is making a link. We want coordinates of C. Oh well, let's talk about it in terms of vector OC. We know vector OA, we know vector AC. OA plus AC is going to give us OC, which is the coordinates of C. Okay, find the coordinates of D given ABCD is a parallelogram. So let's sketch it quickly. And I don't want to rub out here because I might need. So we've got A, we've got B, we've got C, and then we need D here. Let's put the coordinates here, -1, 0, 3. A is 2, 3, 1. And then we've got A, B, C, 1, 4, 1. And then we've got D, which is X, Y, Z. We don't know the coordinates of D. Alright, but because it's a parallelogram, alright, we know a number of things. We know that vector BC, okay, that this vector here is parallel to this vector here. Alright, so that means vector BC is equal to vector AD. Alright, now, vector BC we've got, that's 2, 4, -2. And vector AD is the vector from A to D. It's going to be X take 2. Alright, that's the first component. Y take 3 will be the second component. And then Z take 1 for the last component. And then we just equate the X components. X take 2 equals 2, gives us X is 4. Y take 3 is 4, gives us Y is 7. And we have Z take 1 is -2, gives us Z is -1. Alright, so then the coordinates of point D are not revealed yet. That's vector AD. So we've got vector AD is 4, 7, minus 1. Okay? And then we want the coordinates of D, don't we? So now we just go, okay, well vector OD is the same as vector OA plus AD. Yep. We've got OA, 2, 3, minus 1. So when I add those together, we get 6, 10, and minus 1 is minus 2. So therefore D has coordinates 6, 10, and minus 2. Alright, so let's break down what we did for that one. Okay, so I said we're told that they're in a parallelogram, so that means opposite sides are parallel. We didn't have to do, BC and AD, doesn't matter which ones we use as long as they're the opposite sides. But we said we know vector BC, and vector BC is parallel, which means it has the same direction. And because it's a parallelogram, they have the same magnitude. They're the same distance apart, they're the same distance apart. So that means vector BC equals vector AD. So we made that statement. We solved through for vector AD. This is vector AD, but we want the coordinates of D. We want the coordinates of D. So then we know, oh, well, vector OD is equal to vector OA plus AD. And so we added them, and then that's vector OD, so that's the coordinates of D. All right. So it's a little bit more involved in this exercise, just starts to get a little bit trickier. Just do as much of it as you can, I reckon.